Hello beautiful people, welcome to my new video. In this video, I will be taking you through the architecture of a two-tiered Kubernetes application hosted on AWS within a single region and a single availability zone. This video is going to be just a detailed explanation of the architecture and not a hands-on lab. So, let's get started. The first component in our architecture would be the VPC, which is the virtual private cloud component that would be hosting our Kubernetes cluster. The second component within our VPC would be the subnets. We would be having one public subnet that would be hosting the NAT gateway and the application load balancer, and we would be having two private subnets that would be hosting the EC2 instances that would be running our Kubernetes cluster. Next would be the internet gateway and the NAT gateway. The internet gateway is a very important component. It acts as the gateway for any external traffic to enter into your VPC and reach your Kubernetes cluster. This component gets created by default at the time of VPC creation. The NAT gateway is an optional component, but it is required for the EC2 instances to be able to reach out to the internet and download any packages. Next would be the deployment of the EC2 instances. So first we deploy the master nodes within the master private subnet. The master nodes would be hosting the Kubernetes control plane components. And next we deploy the ingress nodes and the worker nodes in the other private subnet. Please create proper security groups that allow only the intended traffic for the intended ports to be routable within your subnets. This is very important. It's very critical to maintain proper security in production grade clusters. Also, we are having 3 dedicated ingress nodes for ingress purposes and 3 dedicated worker nodes for hosting the application deployment pods. Next would be the deployment of the application load balancer. But before we deploy the application load balancer, we would have to create a target group that would be having the ingress nodes as the backend. So once we've deployed the application load balancer and configured it with the proper rules, it would be listening for the traffic from the internet gateway and forward it back to the ingress nodes. It would load balance the traffic between these ingress nodes. So now that the AWS cluster components have been deployed, we can go ahead with the installation of the Kubernetes software or the Kubernetes API. For this, we can make use of any production grade Kubernetes offerings from many of the open source vendors out there in the industry. Once your Kubernetes software has been deployed, we can go ahead with deploying the ingress pods on the ingress nodes, and then we can deploy the application deployment pods on the worker nodes. So now that the application has been deployed, we can go ahead with creating the Amazon RDS instances and set it up for high availability. One thing to note here is that we have deployed the Amazon RDS instances after the deployment of the application pod. But in many cases, depending on the requirement of the application and the dependencies that the application has, you might have to deploy the database tier or this database layer before deploying the actual application deployment pod. So it is important to understand the dependencies and the application architecture before you deploy the actual resource components. So now that all the cluster components have been deployed, we can also leverage the AWS Route 53 functionality. This is mainly for public domain and allowing name resolution for your Kubernetes cluster externally out on the internet. So now we would be having users out on the internet who would want to access your cluster. So how does the data flow take the appropriate path? First of all, a proper address is fetched from the Route 53 for your cluster domain. Once that address is fetched, the user data traffic is routed to the internet gateway. The internet gateway then further forwards the traffic to the application load balancer, and this application load balancer further forwards the traffic and load balances it between the ingress nodes in a round robin manner. On these ingress nodes, the traffic hits the ingress pods. Now these ingress pods have the necessary routing information It has all the routing configuration for all the pods within your Kubernetes cluster. And finally, these pods then further forward the traffic to the application pods onto the worker nodes. These application pods then do the processing and apply the logic that they have been developed for. And finally, the information is then passed to the database tier and stored onto the Amazon RDS instances. So this is a very basic guideline, a benchmark that you can use for developing your own application architecture on AWS. It's not a strict guideline to follow, but it will give you an idea of how to develop your own architecture. Every organization would be having their own requirements, own security requirements, or a different number of tiers, so you can consider this as a benchmark to develop further your architecture upon.
Thank you for watching this video. I really hope you liked it. Do check out my other video which demonstrates the installation of Red Hat OpenShift 4.10 platform on GCP using the UPI method. And finally, don't forget to like and share this video with your friends and colleagues, and do subscribe to my channel. Thanks again for watching.